Hello, students. In the last topic, we saw in detail about the introduction of satellite communication. In today's topic, we are going to see about satellite system link models. So the entire satellite communication is divided into three major parts. First one is uplink, satellite transponder, and downlink. These three base stations forms an important key role in satellite communication. What is mean by satellite uplink model? In the satellite uplink model, the data which is modulated, the modulated signal is sent to the modulator operation. After performing the modulation operation, a band pass of filters, because after performing a modulation process, the frequency of the signal increases. So we need to send a band of frequency. It will undergoes a band pass filter, and then that band pass filter will go to the mixture process. So we all know mixture will do addition as well as subtraction operation. Addition of signals as well as subtraction of signals. Here using the local oscillator, the microwave generator acts as a local oscillator. The local oscillator will generate a signal, and the band pass filter will transmitted the modulated signal. So addition of these two signals will perform by the mixture. So why this addition of signals is performed means, in order to increase the frequency in the RF signal range. In order to increase the frequency in gigahertz range, we are going to perform addition of signals using the mixture. After performing the addition of signals, the signal is transmitted to the band pass filter again, and high power amplifier will amplify the signal, and using the antenna, the data is transmitted in the air medium. And then this is the second part, which is a transponder. This transponder is placed in the space inside the satellite. The satellite revolve around the earth in its orbit. It depends upon the whether it is an polar orbit or an inclined orbit or an equilateral orbit, or depend upon the application. The distance of the satellite place is also differs. So in the transponder unit, from the earth station, it receives the signal, and it again undergo band pass filter, so the unwanted noises are eliminated, and then low noise amplifier will increases the amplification of the received signals by eliminating the noise. And then here the mixture acts as a subtractor. It will subtract the RF signals, and it will send the intermediate frequency signals into a band pass filter. And then again a high power amplifier will amplify the signals and send to the earth station. This earth station is the receiver earth station. We also call it as a downlink station. So the downlink station will only uses a lesser frequency compared to the uplink frequency. The uplink frequency is always high, so that it needs to reach the transponder in the satellite, and the downlink frequency is comparatively low than the uplink frequency. So in the downlink model, from the satellite transponder, the signal is received by the bandpass filter, and in the bandpass filter, again low noise amplifier. Here the subtraction operation is performed. Why? Because the RF signal is again converted into an intermediate frequency signal, and from the intermediate frequency signal, we need to perform demodulation and separate the actual message signal. Therefore, the mixture or local oscillator signal and the received signal are subtracted each other and again given to the bandpass filter, and again to the high power amplifier will amplify. From this high power amplification, again it goes to demodulated signal, and then the actual message signal is retrieved back in the receiver section. So these three parts combine the satellite communication. So the satellite system link model is a combination of uplink, satellite, and downlink. The uplink frequency is higher than the downlink frequency. Thank you, students.